Okay, let's jump in. We're going to unpack something really interesting today. It's this convergence point between two worlds.
Right.
You have the super specialized world of professional video broadcasting, DVB, and then you have just, regular old internet networks, IP.
It's that moment where these incredibly high-quality, mission-critical video signals finally get to travel over the same kinds of cables you'd find in any office.
Exactly, and much more affordably. So for this deep dive, we're looking at a specific piece of hardware, the Thor Broadcast HASI-IP-B network gateway.
hmm
And the real mission here is to understand the bigger picture. Why does using standard IP suddenly change the whole game for broadcast infrastructure?
It's a fundamental shift.
But before we get into the box itself, let's set the stage. For anyone listening who isn't wiring up a TV studio, what is ASI?
ASI is asynchronous serial interface.
And why was it traditionally so difficult to deal with?
Well, think of it as the professional standard for moving compressed digital video around, specifically MPEG transport streams.
Okay.
And historically, to link two broadcast locations with ASI, you needed very specialized, very dedicated, and frankly, very expensive equipment. We're talking tens of thousands of dollars sometimes, just for one link.
So this gateway, the HSI-IP-B, it basically steps in to be the translator.
Precisely. It breaks you out of that expensive proprietary world. It's an ASI over IP encapsulator.
What does that mean in simple terms?
It takes that special MPEG stream, we call it an MPTS for multi-program transport stream, and it wraps it up into standard IP packets.
Just like any other data on the internet.
Exactly. It uses UDP encapsulation, which is just a reliable way to send it over any standard Ethernet network.
So once that video stream is on an IP network, what can a broadcaster suddenly do that they couldn't before?
Oh, the applications are immediate.
Yeah.
It's perfect for something like an SFN, a single frequency network where you need to sync up multiple transmitters.
Right, synchronization is key there.
And crucially, because it's just IP data now, you can use off-the-shelf hardware. Things like wireless bridges to send that signal across a valley or a city. That was almost impossible, or at least impossibly expensive, with old ASI links.
That's a huge engineering advantage, but we are talking about a full broadcast stream, right? This can be up to, 80 megabits per second of data? How does it stay efficient?
That's the key question, because bandwidth is always the bottleneck.
Always.
And when you look at the specs, it's all about performance and optimization. The real magic trick is how it handles the data load.
Go on.
So ASI streams, by definition, have to include what are called null packets. They're just filler.
Just empty data to keep the rate constant.
Exactly. They're padding. They contain no useful video information at all, but they take up space.
And I'm guessing those add a ton of unnecessary bulk when you're trying to send it over an IP link.
A huge amount. So the gateway is smart. It actively strips out those null packets before it sends the data over the network.
Ah, so you're only sending the actual useful video data.
You got it. And that dramatically cuts down the bandwidth you need, all without touching the actual signal.
Okay, but hold on. If you're stripping out parts of the stream, even if it's just filler, how do you guarantee that timing and sync things that are absolutely critical in broadcast don't get messed up?
That's where the broadcast-grade reliability comes in. The unit uses powerful error correction, like FEC, forward error correction.
To make sure the data arrives intact, even if the network is a bit noisy.
Right, and it also supports full duplex transport. It can send and receive data at the same time over that IP link, which is vital for monitoring and control signals. It's all built on the standard Pro interfaces too, BNC connectors and RJ45 Ethernet.
So to sort of sum it up for everyone listening, this gateway gives you a reliable, bidirectional, and really bandwidth-smart way to move critical video. It turns an old, expensive hardware problem into a standard network engineering problem.
It does.
Huh.
And if we pull back to the biggest picture, it leaves you with a really important thought to chew on. The entire foundation of over-the-air TV, what you watch at home, is now completely and totally reliant on the same kind of internet engineering that runs your web browser. The high-def video on your TV is traveling over the exact same IP architecture as a cat video on your phone. Just think about that for a second. Network engineering has completely taken over television.